Hello, I wanted to make a short video to help you to review the moon diagram that you'll need for our upcoming assessment. This isn't the most thorough diagram. You know, it doesn't have nearly as many components, as many parts as the sun diagram that we've already studied. But it's still good to review this and to have something to which we can refer so that we'll feel confident going into the upcoming assessment. I'm going to start just by writing moon diagram. And we, as you know, start as we draw this diagram. We begin with a shape like that. This is meant to represent the shape of the moon's orbit. And we label this, of course, as an elliptical orbit. Again, elliptical is an adjectival form of the shape known as an ellipse. We also know that this orbit takes a period, or the moon completes its orbit over a period of 29 and a half days. That's 29 and a half days as viewed from Earth. We need to draw our moon, and we're going to draw slightly smaller over here, what will represent Earth. Obviously, these are not to scale. And the only reason we're drawing these two, even though this is a moon diagram, the reason that we're drawing the Earth is because we want to understand different points on the elliptical orbit of the moon in its passage around Earth. The point of the orbit that is closest to Earth is known as the perigee. And remember that the GE here stands for the Greek. It is from the Greek root. G for as we have in geology or something like geography. So the perigee is the point of the moon's orbit that is closest to Earth. The point farthest from Earth in the moon's orbit is known as the apogee. The apogee, again, the G there is for Earth. So close to Earth and far from Earth. We have then features on the moon's surface that we draw and label. First, I'll begin with a couple of craters. Those aren't great circles at all, but these are craters. And we know that this is from the Greek for cup. We like to emphasize roots as much as we can because it helps us when we encounter other scientific words. We have features that we can add to the craters. On this one, I'm going to add a steep wall here that's known as a rim. And on this one, I'm going to add these features that are known as rays. Rays. This is material that's blasted outward from an impact zone. Imagining that space rocks have pummeled the moon in the past, from those points of impact, material is blasted outward, and it's these rays that are produced by that material being blasted outward. Over here, we're going to draw a dark feature. We know that there are these dark, sort of bluish gray features that we can see on the moon on a really, like a good full moon night. We're able to see these areas that are a little bluish gray. And one of these is known as a mare, things that in English we refer to as seas, like the Sea of Rains or the Sea of Tranquility or the Sea of Serendipity. The plural for this is maria. And again, remember that the root here we actually have in a number of words, things like marine or mariner or even mermaid from the same root. We also know that these types of seas, these maria, are filled mainly with volcanic rock known as basalt, extremely widespread type of rock, volcanic rock known as basalt. We also know that we have some features that are often linear or curvilinear that may have carried molten volcanic material into the maria. These are known as rills. Not all rills probably serve that function, but at least some of them are thought to have serve the function of acting as conduits for lava to flow and to fill the maria. The other feature that we'll add on the surface of the moon are mountain ranges. There are mountain ranges, and many of these are named for mountain ranges on Earth. Things like the Alps or Carpathians, European mountain ranges. Some of those same names have been used for naming mountain ranges, mountain chains on the surface of the moon. So we have all of our features from the surface of the moon. We've got craters, again, from the Greek word for cup. We've got rim and rays here. We have a mare, plural maria, filled with basalt. And again, the rill may have been a feature that carried lava into these seas, these maria. Since we finished the surface of the moon features, we're just going to add here the phases of the moon. Again, these phases are manifested over this period of 29 and a half days. So we'll start at the bottom here, just because we'll need a little bit of space, and we'll start with new moon. The new moon is where things begin. You'll remember that previously when I talked about it, we can kind of think of the new moon as no moon. Of course, the moon still exists. It's just that none of it's illuminated at the new moon phase. From there, we're waxing up toward the full moon. And so we have waxing crescent. Remember that crescent rolls smell good. So this has a great scent. There's an SC in here. Remember the SC that we mentioned could remind us of South Carolina's flag. Remember, it's a dark blue flag with a white crescent moon. Remember, South Carolina, you'll remember the spelling of crescent with SC. Then we move to the half moon that's known as first quarter. Even though it's a half moon, it's called first quarter because it's only a quarter of the way through its period. After the first quarter, we have waxing gibbous. Remember that gibbous has two B's. And then here at the top of the diagram, we get to the full moon. After we get to full moon, kind of the whole moon is illuminated here, then it starts to wane. That means it starts to diminish. The amount of the lunar disk that is illuminated is getting less now. So here's where we have the waning gibbous. After the waning gibbous, we're to the third quarter. It's actually the end of the third quarter. Could be called the last quarter as well. It's beginning the last quarter of its period through which it passes. And then we get to the waning crescent. So remember that we have waxing on this side of the diagram. We have waning on this side. On either side of new moon, we have crescent moons because just a little bit of the moon is illuminated at these points. On either side of the full moon, we have something more than a half moon that is illuminated. We have kind of the hunchback moon. And so we have the gibbous moons on either side of the full moon, crescent moons on either side of the new moon, and of course half moons after a quarter here and after a quarter moving off of the full moon here. So that's the moon diagram. That's all that you'll need to know for our upcoming test. Hope you find this helpful. Thanks for listening.